If you've been watching this channel for a while, then you've probably seen my scratch-built QT project, where I use a CO2 laser cutter to cut my own parts from balsa. And if you haven't seen it, go watch it. Anyways, some years ago, I wrote an article in Model Aviation magazine on laser cutting, and one of the things I pointed out is you really needed to use a more powerful CO2 laser, as solid-state lasers were not powerful enough for cutting through wood. Well, I may have to eat those words, as I now have this. It's the AlgoLaser Delta 22 watt desktop laser and engraver, and it's a solid-state laser. Now, the advantage of solid-state diode laser cutters is that they are compact, air-cooled, and have a long life. Unlike the CO2 lasers, which needs a water cooling and uses a vacuum tube that needs to be replaced after a relatively short period of time. Well, all right, let's get into it. This is the AlgoLaser model ALM 20 Bravo Delta. It comes in a nice compact package with easily accessible documentation and some test materials. You get a set of assembly tools and a handy little carrying case, along with some random other parts. That looks like an antenna. 180 watt power supply. What appears to be a diaphragm air pump. USB cable, power cord, and air hose. More test material and some replacement laser parts. But more importantly, you get a pair of protective eyewear specifically for the laser frequency. This is not a toy, and serious eye damage can occur even from reflections. The laser module itself is actually rated at 22 watts with a 445 nanometer wavelength. With everything out of the box, there's really not much to assemble. Manuals are full color and easy to follow, if maybe a little too simplified. The last few pages cover setup with a third-party software, which I'll get to later. Consumable package has, well, consumables. I'm not sure about the paintbrush, maybe for cleaning? But there are random bits of stuff for cutting and engraving. Okay, so the main unit has a prominent power button, emergency stop, and lockout key, all of high quality. On the side are ports for a thumb drive, USB PC connection, air pump control port, and power receptacle. So it looks to be a lens thingy will need to be screwed onto the laser module. It only needs to be hand tight. This module is then slid into the crossbar mount, which has a lever to lock it in place. This makes it easy to adjust the laser distance from the surface. The X-axis crossbar can now be mounted. A nice touch is the machine screws have thread lock pre-applied. Underneath, you'll find the belt tensioner, which is quite loose out of the box. There's one screw to lock it in place. Screw it down just enough to hold it still at first. Then use the other screw to set the tension in the belt. Now go back and lock the other screw into place. There is another tension screw for the Y-axis, but it seemed to be set correctly from the factory. Next are the screw-on feet, the Wi-Fi antenna, and lastly, a magnetically attached laser shield, which only goes on one way. A very nice touch is an integrated focus lever that sets the correct laser distance from the work surface. Just slide it out to set the height, then push the retraction button before cutting the part. And that's it! Assembly is done, and in very short order. The all-metal unit feels smooth and sturdy. The unit doesn't come with a cutting surface, so I purchased one from Amazon. It's a magnetic honeycomb laser platform. Details in the video description below. Amazingly, it fits just perfect underneath the laser. This prevents the laser from damaging the surface of the table. Alright, let's do some cutting. The first test piece will be some simple cardboard. With the focus bar lowered, unlock the laser module and lower it until the bar just touches the cutting surface. Then lock the module back in place. Now retract the focus bar. Glasses on, and power up the laser. Touchscreen is bright and clear with 3 main options: Engraver pattern, manual control, and the settings screen. So in the settings screen, you have quite a few languages available. Oh, Vietnamese! They must have seen my other video. Some screen timeout settings, sound options, USB and systems restoration options. About screen has firmware revision details. While I was at it, I set up the Wi-Fi connection. No issues there. I also noticed a message log icon. Wow, quite a few messages. Looks like I left the emergency stop button down. Neat, it changes color depending on position. Messages can be cleared with the trash icon. On the control screen, there is a motion control option, which allows a manual control of the X and Y axis. But for some reason, the Y axis wasn't moving when commanded. I noticed the Y axis switch was switched to the rotary position. There we go. Now we're cooking with oil. For a quick start, you can plug in a USB drive. There is apparently a built-in SD card, but I want to access the thumb drive, where I can load a graphics file to engrave. There we go, my channel logo. Hit the engrave button. I noticed material options, so I chose wood. There are other options like quality, power settings, and number of cutting passes. Press start processing, then engrave. It was moving, but no laser activity. I checked the error log and found a few entries, including something about requiring homing. Dope! I forgot about that. I made sure to hit the home button in the settings. While I was at it, I checked for firmware updates. Then I remembered to press the range preview button, which shows the area where the laser will cut to piece. I also remembered to hook up the air pump. There's also a manual power controller for the fine-tuning of the pump power. Alright, nursing my pride, I restarted the engraving. After a few quiet passes, I see the top LEDs come to life, and I smell that old friend of burning material. It's alive!
Woohoo, it's breathing!
Within a few minutes, my graphic image was now on a piece of cardboard.
Alright, so... Oh, wait. Safety first. So, I got my first successful cut, etch, engrave. Just a simple piece of cardboard, and I got it to work. Turns out I needed to do the, not homing, but sort of the perimeter check first. Like I said, it requires you to do push the button to do the perimeter check so you know where your work area is, and then you can go into the cutting mode and be patient. The second part was I wasn't quite patient. It was moving back and forth. I was like, why isn't that cutting? Well, it had to work its way down through the image file till it got to the high contrast area, the dark area where it started cutting. And there we go. I've got, there you go. Please like and subscribe. That was just a simple GIF I imported. I have not installed any software on my PC yet. This was just a graphics file. I think a JPG or PNG. It does both. At least those two, maybe more, probably GIFs as well, that I just put on a thumb drive, stuck it in, and selected, and there we go. It's probably, this is a bit of an art. I've used too much power because I was worried the first time I used less power. My instincts were right not to use so much power, but it wasn't burning anything, so did I have enough power? So I'll probably do another print with less power to see how it works. Cardboard is just paper, very thin. And then once that's done, then I'm going to go and see about installing some software on my PC so that I can connect to this and upload vector files. Now, vector files are what we really need if I'm going to do cutting for balsa parts for model airplanes or parts for anything really. You need to do vector files. The graphics files are only good, raster they call them, only good for doing images on as engraving. They're not accurate enough or really good enough for doing actual parts that you want to cut out. But for engraving, it's perfectly fine, and I'm going to experiment with maybe different colors and see how that works and whatnot. But it's neat that you can just plug in a thumb drive with a graphics file and just get right to work pretty much immediately. And that was real good. So I'm real happy that it works. The machine seems to be working pretty good. It looks really good, and I think I am going to like this. And so let's get on to installing some software and see what else I can cut and burn. Yeah, lasers to full power.
Alright, so the next step is to hook up my PC so I can remotely control the AlgoLaser. It's connected by the USB-C cable. Windows 10 auto-loaded the driver, and the free program Laser Gerbil had no problem connecting up to the laser. Manual controls work like a charm. Laser Gerbil is an engraving program, so I loaded up another raster image, this time in some grayscale. There are some power and size settings, but I left the default for now. The preview image seemed to have some gaps in the lines, but we'll see how the cut looks. To check the work area, I selected the frame button. Alright, press the button, Frank. This time I use a regular piece of paper. Ooh, look at that bright laser. Good thing I was using protection. It worked well enough, but obviously way more power than needed. I changed some power settings and upgraded to 1/16 inch balsa. But it still cut through the balsa like a hot knife through butter. So I reduced the power to only 10% and tried again. Much better, but now I can see those lines I mentioned before. There is a quality setting to improve the engraving resolution, which improved the preview image, so let's see how it translates. Much better, and now I can also see the finer details. The program also has an option to turn images into line art, which worked really good. Yeah. All right, so I was pretty happy that I was actually pretty easily and quickly able to use the Laser Gerbil, or is it Gerbil, software to connect to the laser cutter and print out some stuff. And it worked really quite slickly, and I was able to easily kind of tweak with the settings, and I still have some more to do with some of the laser power settings and so forth. But I'm happy that I was actually pretty easily able to cut through 1/16 inch balsa without even trying. So that I'm really that gives me encouragement that I can do even thicker wood and maybe denser wood. Now the only thing is with this Laser Gerbil software is that it apparently does not import vector files like DXF and CAD files and so forth. And that's what I'm really going to need in order to do stuff like laser cutting my own kits and pieces and parts. So there's a solution for that. It's a program called Lightburn, and it's not free, but it's not very much money. So I am going to purchase that and install it and try that out. And that'll allow me to do some more in-depth testing. It turns out that Lightburn has a free 30-day trial, so there's no risk in trying it out. It's a quick and easy install, though it has a few more steps than the previous program. I can even give the laser a custom name. Since Lightburn is designed to do engraving and cutting, I use a built-in drawing tool to make a simple shape to cut. There's a handy screen for setting power, speed, and number of passes. I selected 20% power as a starting point. As expected, there is a framing button and a very clear start button. Ha! That was quick. Well, a little too quick as it barely cut anything. Let's try slowing it down a bit. A little better. Alright, let's give it more power. And a little slower. Oh yeah, success! Looking at the import options, I see Lightburn supports a myriad of file types, including the important vector files. To test this, I loaded up my self-created vector files from my Qt project. It loaded it, but the scale was off. No doubt something in the settings needed changing. I'll fix that later, but in the short term, I could manually change the scale. Okay, with the burning software up and running, it was time for some in-depth testing. So I grabbed whatever I could find in the workshop. Alright, AlgoLaser, let's see what you got. First up was some fairly dense 1/8" balsa. Before I start, I should also note that there is a cheat sheet available from the company for setting the laser to cut different materials. Though for some reason, I didn't see balsa listed. So I took an educated guess on some settings, and it cut through no problem. I should note that these tests will limit the laser power to 90% to help prolong laser life. Next up was some 1/8" basswood. Ooh, a bit more smoky on that one. Again though, a nice clean cut through. Moving on to plywood, something thin at first. Looking good so far. Even 2mm ply was a piece of cake. I decided to try some 2mm styrene. First try barely crashed the surface. So I scaled back to a really thin piece of styrene. Even that didn't work. So I slowed down the speed some. And that seemed to do the trick. I was also able to cut through 1mm thick styrene. But that seemed to be about as thick as the laser would do. I had some what I think is 1/16" clear acrylic, but it only cut the protective sheeting.
Well, I did a quick bit of research, and it turns out that diode lasers are the wrong wavelength to cut clear acrylic. So it looks like that's going to be a no-go for me on acrylic, unfortunately. Oh well, you can't have everything. But I have a couple other weird things I think I want to try to cut out, and let's see how that works.
So next up was some foam board from an old flight test plane. Well, it cut, but not very clean at all. Yikes. I tried at various settings, but it was either too much or too little. Even then, there seemed to be some overheating of the foam. I think I'll move on for now until I do a little more research. Out of curiosity, I grabbed a sheet of Ultracoat heat shrink covering. It didn't want to lay flat, so I added some weights to hold it down. It worked pretty good. I think this could come in handy making patterns and decals. I also imported another vector file of parts and cut out a whole sheet of stuff. And then I saw something strange. Many of the lines were really squiggly. What the heck? I wonder if the head was loose. So I checked the belt tensions and roller wheels, which frictions can be adjusted. That helped, but only very slightly. On a hunch, I lowered the power and slowed the cutting speed down. Yes, the new results are on the bottom sheet, and much better. Squigglies are pretty much all gone. That seemed to indicate that it is what's called ringing, which is overshoot from moving too fast. I found some acceleration settings in Lightburn, which should help. I'll test it out later, but for now, slower cutting speeds will work. Also, one thing that bugged me is I couldn't accurately tell the cutting area of the laser. So I added some tape markers to the laser module. I also noticed the laser emitter was not quite equal distance from the sides. Alright, back to the last few tests. 1/4" balsa. Ha ha ha, that was left-handed. Alright, time to get real. 1/4" light ply. Note that I found the settings to change the speed from millimeters a second to millimeters a minute to match the company's settings data sheet. Anyways, yes, 1/4 inch ply was not a problem. Even thicker ply should be possible. Okay, how about some 1/4 inch medium density fiberboard? I was a bit apprehensive, but it's listed in the cheat sheet, so let's see if they're right. Breaking with tradition, I went up to 100% power. Holy smokes, it worked! I played with different power settings and speeds, but what the company recommended seemed to work best. Well, okay, call me impressed. This AlgoLaser is quite nice. I mean, really nice. It's quite better than I expected, actually. Now, for a tabletop laser, it's surprisingly capable. Yes, there are some limitations due to power and the visible laser frequency, but for a scratch building hobbyist, I think it's quite useful and a must-have. Now, I've been wanting my own personal laser for a workshop, and the AlgoLaser fits the bill quite nicely. It's compact, yet powerful enough to meet most of my needs. The structure is quite sturdy and easy to take apart for maintenance. Now, the company claims the laser emitter should last greater than 10,000 hours, so hopefully that's not an exaggeration. Now, as far as accuracy, well, we'll explore that in part 2, where I try to cut out some stuff to build. Hi, thanks for watching. Please take a look at the video description below for special HobbyView sales and discounts. Your purchases help support this channel. Happy modeling!